Close your eyes for a moment and let yourself drift into the infinite expanse of the universe. Picture the endless darkness, dotted with shimmering stars and swirling clouds of light. Now, imagine something so small, so delicate, yet so powerful that it holds the key to the birth of entire worlds. This is the story of cosmic dust, the silent architect of planets, the quiet builder of solar systems. These tiny particles, no larger than grains of sand, float through the void, carrying within them the secrets of creation. Tonight, as you settle in, we'll take you on a journey through the cosmos, where gravity weaves its magic and cosmic dust becomes the foundation of planets. Let your mind wander through the stars, and as you listen, feel the gentle pull of the universe, guiding you into a peaceful, dreamlike state. Where are you joining us from, and what time is it there? Let the vastness of space remind you of how small yet connected we all are. Now, let's begin our journey into the heart of the cosmos, where the story of cosmic dust unfolds. Now, let's take a closer look at what cosmic dust truly is. Imagine the finest grains of sand, so small they seem almost invisible, yet when gathered together, they create something extraordinary. Cosmic dust is made up of tiny particles, often no larger than a fraction of a millimeter, composed of minerals, metals, and even organic compounds. These particles are the remnants of ancient stars, the debris left behind after a star's fiery death, or the fragments scattered by the collisions of asteroids and comets. Picture these particles as the universe's building blocks, drifting silently through the vast emptiness of space. They shimmer faintly, catching the light of distant stars, creating a delicate glow that adds to the beauty of the cosmos. Though they may seem insignificant on their own, these tiny specks of dust are the seeds from which planets, moons, and even entire solar systems grow. As you listen, imagine these particles floating in the darkness, each one carrying the potential to become part of something much greater. Now, let's journey deeper into the cosmos to uncover the origins of cosmic dust. Picture a star, not unlike our own sun, reaching the end of its life. In its final moments, it swells into a red giant, casting off its outer layers in a brilliant explosion of light and energy. This stellar farewell, known as a supernova, scatters the star's remains across the void, leaving behind a shimmering cloud of gas and dust. These remnants, rich in elements like carbon, silicon, and iron, become the raw materials for cosmic dust. But stars aren't the only source. Imagine two asteroids hurtling through space, colliding with incredible force. The impact shatters them into countless fragments, some so small they become part of the cosmic dust that drifts through the galaxy. These tiny particles, born from both the fiery deaths of stars and the violent collisions of celestial bodies, are the universe's way of recycling itself, creating the very ingredients needed to build new worlds. As you listen, envision these cosmic events, supernova lighting up the darkness, asteroids crashing together, each one a step in the grand process of creation, where even the smallest speck of dust holds the potential to shape the future of the cosmos. Now, let's drift further into the cosmos, where cosmic dust finds its home in the most breathtaking of places, nebulas. Imagine vast, swirling clouds of gas and dust, stretching across light years, glowing with hues of deep reds, vibrant blues, and soft purples. These are the stellar nurseries of the universe, where cosmic dust gathers in such abundance that it forms the very fabric of these celestial masterpieces. Picture the Orion Nebula, one of the most famous, its dust and gas illuminated by the light of newborn stars, creating a tapestry of color and light that seems almost otherworldly. Within these nebulas, cosmic dust plays a vital role, acting as both a canvas and a catalyst. It absorbs and scatters light, giving nebulas their ethereal glow, while also providing the raw materials needed for new stars and planets to form. As you listen, let your mind wander through these cosmic clouds, where every particle of dust is a brushstroke in a painting that spans the universe. These nebulas are not just beautiful, they are alive with possibility, cradling the seeds of future worlds in their shimmering embrace. Now, let's follow the quiet journey of cosmic dust as it begins its voyage through the vast expanse of space. Picture these tiny particles, no larger than grains of sand, drifting effortlessly in the darkness. They are carried by the gentle push of stellar winds, the breath of stars, and the invisible pull of gravity, the universe's guiding hand. This journey is not hurried or chaotic. It is a slow, deliberate dance, a cosmic waltz that unfolds over millions of years. Each particle moves with a serene grace, gliding through the void, sometimes alone, sometimes joining others in a delicate swirl. As they travel, they pass by stars, planets, and even other clouds of dust, their path shaped by the forces that govern the cosmos. It's a journey of quiet persistence, where even the smallest particles play a part in the grand story of the universe. And as you imagine this tranquil movement, let it remind you of the beauty and stillness, the power of patience, and the quiet strength of these tiny travelers, destined to become part of something much greater. As the cosmic dust continues its quiet journey through the vastness of space, something remarkable begins to happen. The force of gravity, that invisible thread woven through the fabric of the universe, starts to gently tug at these tiny particles. Imagine gravity as a quiet whisper, calling the dust closer, drawing it into a delicate embrace. At first, the movement is almost imperceptible, a slight shift, a subtle pull. But over time, this gentle force grows stronger, guiding the particles toward one another. Picture these specks of dust, once scattered and solitary, now slowly drifting closer, drawn by the quiet power of gravity. They begin to gather, forming small clumps that grow larger with each passing moment. It's a process that unfolds over millions of years, a slow and steady dance where gravity plays the role of both choreographer and conductor. Each clump becomes a tiny seed, a promise of something greater to come. As more dust is pulled in, the clumps grow denser, their gravitational pull increasing. What begins as a faint whisper becomes a steady hum, a rhythm that echoes through the cosmos. This is the universe's way of building, one particle at a time, creating the foundations of future worlds. And as you imagine this gradual, almost meditative process, let it remind you of the quiet power of persistence, how even the smallest actions, repeated over time, can lead to something extraordinary. Now, as we drift further into this cosmic tale, let's take a closer look at these tiny clumps of matter, the first seeds of what will one day become planets. Picture this: in the vast, silent expanse of space, where time moves at a pace almost beyond comprehension, these small gatherings of cosmic dust begin to take shape. It's a process so gradual, so delicate, that it feels almost magical, a quiet miracle unfolding in the darkness. Each clump, no larger than a grain of sand at first, is a testament to the power of gravity's gentle pull. Over countless years, more and more particles are drawn in, sticking together in a slow, steady accumulation. These clumps are not just random collections of dust. They are the universe's first steps toward creating something far greater. Imagine them as tiny, fragile sculptures, each one a promise of a future world. As these clumps grow, they begin to take on a life of their own. Their gravitational pull strengthens, drawing in even more dust and debris from their surroundings. What starts as a faint, almost invisible gathering becomes a small but significant presence in the cosmos. It's a process that feels almost poetic, a quiet dance of creation, where the smallest particles come together to build the foundations of planets. And yet, there's a simplicity to it all. No grand explosions, no dramatic collisions, just the steady, patient work of gravity, pulling and shaping, one particle at a time. It's a reminder that even the most monumental creations often begin with the smallest, quietest steps. As you imagine these clumps of matter, let them inspire you with their quiet persistence, their slow but certain journey toward becoming something extraordinary. This is the universe's way of building, a process as old as time itself, and one that continues to shape the cosmos even today. And as we move forward, we'll see how these humble beginnings lead to the formation of even larger structures, setting the stage for the birth of planets. Now, as we gently shift our focus, let's explore the quiet yet transformative role of collisions in this cosmic story. Imagine these tiny clumps of dust, drifting through the vast emptiness of space, occasionally meeting one another in a delicate, almost choreographed encounter. These collisions are not violent or chaotic. They are gentle, like the soft brushing of hands in a slow dance. Each time two particles meet, they stick together, bound by the same forces that brought them into existence. Over time, these small encounters add up. A grain of dust meets another, and together they form a slightly larger grain. This new, slightly heavier clump now has a stronger gravitational pull, attracting even more particles. It's a process that feels almost like a cosmic snowball effect, where each collision builds upon the last, creating something larger and more substantial. Picture these particles as dancers in an endless ballet, moving gracefully through the darkness. Each step, each touch, brings them closer to becoming something greater. The collisions are not random. They are guided by the invisible hand of gravity, pulling these particles together in a slow, steady rhythm. It's a dance that has been happening for billions of years, a dance that continues to shape the universe even now. And yet, there's a beauty in the simplicity of it all. No grand explosions, no dramatic crashes, just the quiet, persistent work of particles coming together, one gentle collision at a time. These small, seemingly insignificant moments are the building blocks of planets, the foundation upon which entire worlds are formed. As you imagine these cosmic dances, Let them remind you of the power of persistence and connection. Even the smallest actions, when repeated over time, can lead to something extraordinary. And as we move forward, we'll see how these growing clumps of dust begin to take on new forms, setting the stage for the next chapter in the story of planet formation. Now, as we drift further into this cosmic journey, let's take a closer look at how these growing clumps of dust begin to evolve into something even more remarkable. Picture the tiny grains, now slightly larger from their gentle collisions, continuing their slow dance through the vastness of space. Over time, these clumps grow heavier, their gravitational pull becoming stronger, drawing in more and more particles. It's a process that feels almost like the universe knitting itself together, one stitch at a time. As these clumps grow, they begin to take on new forms, becoming what scientists call planetesimals. These are the building blocks of planets, the first true steps toward the creation of worlds. Imagine them as small, rocky bodies, ranging in size from a few meters to several kilometers across. They are not yet planets, but they are the seeds from which planets will one day grow. The transformation from dust to planetesimals is a slow and steady one, guided by the same forces that have shaped the universe since its beginning. Gravity continues to pull these clumps together, while collisions, still gentle and deliberate, help them grow. Each encounter adds a little more mass, a little more structure, until what was once a scattered cloud of dust begins to resemble something solid and stable. There's a quiet beauty in this process, a sense of purpose that feels almost poetic. These planetesimals are not just random collections of rock and dust. They are the first hints of order in a chaotic universe. They are the promise of worlds yet to come, the foundation upon which entire solar systems will one day stand. As you imagine these early planetesimals, think of them as the universe's way of laying the groundwork for something extraordinary. They are the quiet architects of planets, working tirelessly in the background, unseen and uncelebrated. And yet, without them, the planets we know today, Earth, Mars, Jupiter, and all the others, would never have come to be. This slow but steady transformation reminds us that even the grandest creations begin with the smallest steps. From dust to clumps, and from clumps to planetesimals, the universe is always moving forward, always building towards something greater. And as we continue our journey, we'll see how these planetesimals take the next step in their evolution, setting the stage for the birth of planets themselves. Now, as we move deeper into this cosmic tale, let's explore how these planetesimals take the next step in their journey, transforming into something even more significant. Picture these small, rocky bodies, once scattered and independent, now beginning to come together in a slow, deliberate dance. Over time, gravity pulls them closer, and their gentle collisions grow more frequent, merging them into larger and larger bodies. These are the protoplanets, the early versions of the planets we know today. Imagine these protoplanets as young worlds in the making, still rough and unpolished, but already showing the potential for greatness. They are not yet fully formed, but they are no longer just clumps of dust and rock. Instead, they are growing into distinct bodies, each with its own unique characteristics. Some may be rich in metals, while others are composed of lighter materials. setting the stage for the diversity of planets we see in our solar system. This process of merging is not sudden or violent. It's a gradual, almost serene transformation. Each collision adds a little more mass, a little more structure, until what was once a collection of planetesimals begins to resemble a true planet. It's as if the universe is patiently sculpting these young worlds, one piece at a time, ensuring they grow strong and stable. There's a quiet elegance to this stage of planetary formation. The protoplanets are not yet complete, but they are already beginning to shape the future of their solar system. They are the bridge between the chaos of cosmic dust and the order of fully formed planets, a testament to the universe's ability to create beauty out of simplicity. As you envision these protoplanets, think of them as the universe's way of preparing for something extraordinary. They are the foundation upon which entire worlds will one day stand, the quiet promise of planets yet to come. And as we continue our journey, we'll see how these protoplanets take their final steps toward becoming the planets we know and love, completing the cosmic story that began with a single grain of dust. Now, let's step back in time to a moment when our solar system was still in its infancy. Imagine a vast, swirling sea of cosmic dust, stretching across the darkness of space like a shimmering veil. This was the early solar system, a place of chaos and creation, where the building blocks of planets were just beginning to take shape. In this ancient scene, young protoplanets drift through the haze, their surfaces still rough and unformed. Around them, cosmic dust swirls in graceful spirals, caught in the pull of gravity and the gentle push of stellar winds. It's a dance of creation, slow and deliberate, as the universe works to shape these young worlds into something greater. The dust itself is everywhere, a fine, glittering mist that fills the space between the protoplanets. Some of it clings to their surfaces, adding layer after layer of material, while the rest continues to drift, waiting for its moment to join the growing bodies. This dust is more than just debris. It's the raw material of planets, the foundation upon which entire worlds will one day stand. As you picture this scene, notice the quiet beauty of it all. There's no rush, no urgency, just the steady, patient work of gravity and time. The protoplanets grow slowly, their shapes becoming more defined with each passing eon. Some may collide, merging into larger bodies, while others continue to gather dust, growing in size and strength. This is the early solar system, a place of endless possibility. It's a world in the making, where every grain of dust plays a part in the grand story of creation. And as we watch this ancient scene unfold, we can't help but marvel at the universe's ability to turn chaos into order and dust into worlds. As we move forward, we'll see how this swirling sea of dust and protoplanets gives rise to the planets we know today, completing the journey from cosmic dust to fully formed worlds. But for now, let's linger in this moment, appreciating the quiet beauty of the early solar system, where the seeds of planets were first sown. Now, let's turn our gaze closer to home, to a time when Earth itself was just a dream, taking shape in the vast expanse of the early solar system. Picture a young Earth, not yet the blue and green oasis we know today, but a fiery, molten world cloaked in a thick haze of cosmic dust. This was a time of transformation, where the raw materials of our planet were being gathered and shaped by the forces of the universe. Cosmic dust played a vital role in this process, drifting through space and settling onto the growing Earth. Each tiny particle added to the planet's mass, building it layer by layer over millions of years. The dust was more than just debris. It carried with it the essential ingredients for Earth's formation, from metals and minerals to the very elements that would one day give rise to life. As Earth grew, its surface was a chaotic, molten landscape, constantly reshaped by the heat of its formation and the impacts of other cosmic bodies. The dust that settled on its surface was quickly swallowed by the churning magma, becoming part of the planet's core and mantle. Over time, as Earth cooled, the dust that remained on the surface began to form the first solid crust, a thin shell that would one day become the foundation for continents and oceans. But the story of cosmic dust doesn't end there. Even as Earth's surface began to solidify, dust continued to rain down from space, bringing with it water and organic molecules. These precious materials, carried on the backs of tiny dust particles, would eventually play a crucial role in shaping Earth's future, setting the stage for the emergence of life. As we reflect on Earth's early days, it's remarkable to think that something as small and seemingly insignificant as cosmic dust could have such a profound impact. From the molten chaos of its formation to the delicate balance of its surface, cosmic dust was there every step of the way, quietly shaping the world we call home. And as we move forward, we'll see how this dusty beginning laid the groundwork for Earth's transformation into a living, breathing planet. But for now, let's take a moment to appreciate the quiet, patient work of cosmic dust, the unsung hero of our planet's creation. Now, let's drift into the next chapter of this cosmic tale, where we explore how cosmic dust became a messenger of life itself. Imagine, for a moment, the vast emptiness of space, dotted with countless specks of dust, each one a tiny vessel carrying the most precious cargo: water. Water, the essence of life, is thought to have arrived on Earth not in rivers or oceans, but on the backs of these minuscule particles. Cosmic dust, drifting through the cold void, often contains tiny ice crystals or water molecules trapped within its structure. As these particles journeyed through the early solar system, they were drawn to young planets like Earth by the pull of gravity. Picture this: a gentle rain of cosmic dust falling onto the molten surface of a young Earth. Each particle that landed brought with it a tiny droplet of water, a gift from the stars. Over millions of years, this steady drizzle of dust and ice began to accumulate, slowly but surely adding to the planet's water reserves. But how did this water survive the intense heat of Earth's early days? Some scientists believe that much of the water was delivered later, during a period known as the Late Heavy Bombardment, when comets and asteroids rich in water and cosmic dust pummeled the planet. These impacts released water vapor into the atmosphere, which eventually cooled and condensed, forming the first oceans. It's a humbling thought, isn't it? That the water we drink, the oceans we swim in, and the rain that nourishes our planet may have traveled across the cosmos, carried by the quiet, unassuming particles of cosmic dust. This dusty delivery system didn't just bring water, it brought the potential for life, setting the stage for the incredible diversity of organisms that would one day call Earth home. As we ponder this cosmic connection, let's take a moment to marvel at the intricate dance of the universe, from the tiniest speck of dust to the vast oceans that cover our planet. Every element of this story is a reminder of how interconnected we are with the cosmos. And as we continue our journey, we'll see how cosmic dust played yet another vital role in the story of life, this time by delivering the building blocks of organic molecules. But for now, let's rest in the quiet beauty of this moment, where water and dust come together to create the foundation of life itself. Now, let's turn our gaze to another remarkable chapter in the story of cosmic dust, one that brings us closer to understanding the very origins of life. Among the countless particles drifting through the cosmos, cosmic dust carries something even more extraordinary than water: organic molecules. These tiny chemical compounds, often referred to as the building blocks of life, are the essential ingredients for the complex chemistry that makes life possible. Imagine these organic molecules nestled within the grains of cosmic dust, traveling across the vast expanse of space. They include simple compounds like amino acids, the very same molecules that form proteins in all living organisms. How did these molecules come to be? Some are forged in the hearts of dying stars, while others form in the cold, dark clouds of interstellar space, where cosmic dust gathers in dense nebulas. Over time, these molecules become embedded in the dust, preserved like tiny time capsules waiting to be delivered to new worlds. When cosmic dust settles on a young planet, it brings with it these organic molecules, scattering them across the surface like seeds in a cosmic garden. On Earth, for example, this dust may have played a crucial role in the emergence of life. Scientists believe that the organic molecules delivered by cosmic dust could have interacted with the planet's early environment, sparking the chemical reactions that eventually led to the first living cells. It's a quiet, almost magical process, one that unfolds over millions of years, hidden from view, yet essential to the story of life. What's even more fascinating is that cosmic dust doesn't just deliver these molecules, it also protects them. The tiny grains act as shields, safeguarding the delicate organic compounds from the harsh radiation and extreme temperatures of space. This protective role ensures that the molecules arrive intact, ready to contribute to the chemistry of life on a new world. As we reflect on this, it's awe-inspiring to think that the same dust that forms planets and stars also carries the potential for life itself. Cosmic dust, often overlooked in its simplicity, becomes a silent architect of complexity, weaving together the threads of chemistry, water, and energy to create the conditions for life to emerge. And as we continue to explore the cosmos, we may yet discover more about how this humble dust has shaped not only our planet, but perhaps countless others across the universe. With this in mind, let's take a moment to appreciate the quiet, mysterious role of cosmic dust, a role that reminds us of the profound connections between the stars, the planets, and the very essence of life. And as we move forward, we'll see how this story extends beyond our own solar system, into the realm of distant stars and the planets that orbit them. Now, let's journey beyond Earth and explore how cosmic dust has shaped the other planets in our solar system. Each planet, from the rocky surfaces of Mercury and Mars to the swirling atmospheres of Jupiter and Saturn, carries the fingerprints of cosmic dust in its formation. Take Mars, for example. This red planet, often called Earth's sibling, was once a world rich with water and possibly even the conditions for life. Cosmic dust played a key role in delivering the water and organic molecules that may have once flowed across its surface. Even today, Martian dust storms, which can engulf the entire planet, are a reminder of the fine particles that continue to shape its environment. These storms, driven by the same cosmic dust that helped form the planet, create a dynamic and ever-changing landscape. Moving outward, we encounter the gas giants Jupiter and Saturn. These massive planets, with their swirling storms and intricate ring systems, owe much of their composition to cosmic dust. In the early solar system, cosmic dust clumped together to form the cores of these giants. Over time, these cores grew large enough to capture vast amounts of gas, creating the colossal planets we see today. Even their iconic rings, made up of countless tiny particles, are a testament to the enduring presence of cosmic dust in their orbits. Then there are the icy worlds, like Uranus and Neptune. These distant planets, shrouded in cold and mystery, also bear the marks of cosmic dust. The dust that settled in the outer reaches of the solar system contributed to the formation of their icy cores and the complex chemistry of their atmospheres. It's fascinating to think that the same dust that helped create Earth's oceans may have also played a part in shaping the frozen landscapes of these far-off worlds. Even the smallest bodies in our solar system, like asteroids and comets, are deeply connected to cosmic dust. These objects, often referred to as the leftovers of planet formation, are rich in dust and organic materials. When comets pass close to the sun, they release trails of dust that light up the night sky as meteor showers. These showers are a beautiful reminder of the ongoing role cosmic dust plays in our solar system, even billions of years after its formation. As we reflect on the diverse worlds within our solar system, it's clear that cosmic dust is a universal architect. From the rocky surfaces of inner planets to the icy realms of the outer solar system, this humble dust has shaped the very fabric of our cosmic neighborhood. And as we continue to explore these worlds, we uncover more about the intricate processes that brought them into being, processes that began with the tiniest grains of dust drifting through the void of space. With this in mind, let's turn our attention to the broader universe, where cosmic dust continues to shape planets far beyond our solar system, weaving its story into the tapestry of countless stars and worlds. Now, let's venture beyond the familiar boundaries of our solar system and into the vast expanse of the universe, where cosmic dust continues its quiet work of creation. Far beyond the reach of our sun's light, countless stars shine in the darkness, each surrounded by swirling clouds of dust and gas. These stellar nurseries, much like the one that birthed our own solar system, are the birthplaces of planets orbiting distant stars, worlds we call exoplanets. In these far-off systems, cosmic dust plays the same foundational role it did here. Tiny particles, born from the remnants of ancient stars or the collisions of asteroids, gather in vast clouds around young stars. Over time, Gravity begins to pull these particles together, forming clumps that grow larger and larger. These clumps, much like the ones in our early solar system, become the seeds of future planets. But the story doesn't end there. The diversity of exoplanets we've discovered, ranging from rocky super-Earths to gas giants larger than Jupiter, shows just how versatile cosmic dust can be in shaping worlds. One fascinating example is the formation of hot Jupiters, gas giants that orbit incredibly close to their stars. Scientists believe these planets likely formed farther out in their systems, where cosmic dust was abundant, and then migrated inward over time. The dust that helped create their massive cores also played a role in their journey, interacting with the star's gravity and the surrounding disk of material. This process highlights the dynamic and ever-changing nature of planetary systems, all driven by the humble grains of cosmic dust. But it's not just gas giants that owe their existence to cosmic dust. Rocky exoplanets, some of which may resemble Earth, also form from the same building blocks. In systems where dust is rich in metals and silicates, planets with solid surfaces can emerge. Some of these worlds may even lie within their star's habitable zone, where conditions could allow liquid water, and perhaps life, to exist. The dust that delivers water and organic molecules to these planets could be the key to understanding whether life exists beyond our solar system. Even more intriguing are the systems where cosmic dust forms planets around not one, but two stars. In binary star systems, dust must navigate the complex gravitational dance between two stars, creating planets that orbit both. These worlds, often called circumbinary planets, are a testament to the resilience and adaptability of cosmic dust, which finds a way to build planets even in the most challenging environments. As we peer deeper into the cosmos, we continue to uncover the incredible diversity of exoplanets, each with its own unique story of formation. And at the heart of each story lies cosmic dust, a silent yet powerful force that shapes worlds across the universe. From the fiery surfaces of hot Jupiters to the icy realms of distant super-Earths, this dust weaves a tapestry of creation that stretches across the stars. With this in mind, let's turn our gaze to the beauty of cosmic dust itself, not just as a builder of worlds, but as a shimmering presence that lights up the cosmos in ways that inspire awe and wonder. As we shift our focus, let's take a moment to appreciate the sheer beauty of cosmic dust, a quiet artist painting the canvas of the universe. Imagine vast clouds of dust and gas, illuminated by the light of newborn stars, glowing in hues of deep reds, vibrant blues, and soft purples. These nebulas, often called the jewels of the cosmos, are not just stunning to behold, they are the very cradles of creation, where stars and planets begin their journey. Each particle of dust, though tiny and seemingly insignificant, plays a part in crafting these breathtaking cosmic landscapes. In the darkness of space, cosmic dust catches the light of distant stars, scattering it in all directions. This interaction creates phenomena like reflection nebulae, where dust acts as a cosmic mirror, reflecting starlight and giving the nebula a soft, ethereal glow. It's as if the universe itself is putting on a light show, with dust as its star performer. And then there's the zodiacal light, a faint, ghostly glow visible just after sunset or before sunrise. This light is caused by sunlight reflecting off countless dust particles scattered throughout our solar system, a reminder that even in the vast emptiness of space, beauty can be found in the smallest of things. But the beauty of cosmic dust isn't just visual, it's also symbolic. These tiny particles, born from the remnants of ancient stars, carry within them the history of the universe. They are the remnants of supernovae, the ashes of stellar giants, and the seeds of future worlds. In their shimmering presence, we see the cycle of creation and destruction, a dance that has been playing out for billions of years. Every grain of dust is a testament to the resilience and creativity of the cosmos, a reminder that even in the cold, dark void of space, there is life, light, and endless possibility. As we gaze at the night sky, let's remember that the stars we see are not alone. They are surrounded by clouds of cosmic dust, each particle a silent witness to the grandeur of the universe. Whether it's the swirling colors of a distant nebula or the faint glow of zodiacal light, cosmic dust reminds us that beauty exists in every corner of the cosmos, waiting to be discovered. And in that discovery, we find not just wonder, but a deeper connection to the universe itself. Now, let's turn our attention to the delicate interplay between cosmic dust and light, a dance that paints some of the most mesmerizing scenes in the universe. Picture a beam of starlight piercing through the darkness, only to meet a cloud of cosmic dust. As the light encounters these tiny particles, it scatters in all directions, creating a soft, glowing halo around the stars. This is the magic of reflection, nebulae, where dust acts as a cosmic canvas, reflecting and diffusing light to produce ethereal, dreamlike landscapes. The result is a celestial masterpiece, where stars seem to shimmer within a veil of luminous dust, their light transformed into a gentle, otherworldly glow. But the interaction between cosmic dust and light doesn't stop there. Consider the zodiacal light, a faint, triangular glow that appears in the night sky just after sunset or before sunrise. This subtle radiance is caused by sunlight reflecting off countless dust particles scattered throughout the inner solar system. These particles, remnants of comets and asteroid collisions, form a vast, dusty disk that encircles the sun. When sunlight hits this disk, it creates a soft, ghostly light that seems to rise from the horizon, a quiet reminder of the cosmic dust that surrounds us even in our own celestial neighborhood. What makes these phenomena so captivating is not just their beauty, but the way they reveal the hidden presence of cosmic dust. Without dust, the universe would be darker, less colorful, and far less dynamic. It's the dust that catches the light, bending and scattering it to create the stunning visuals we associate with the cosmos. From the vibrant hues of nebulas to the subtle glow of zodiacal light, cosmic dust transforms the way we see the universe, adding depth, texture, and wonder to the night sky. As we marvel at these celestial displays, we're reminded of the quiet yet profound role that cosmic dust plays in shaping our view of the cosmos. It's not just a passive observer, but an active participant, shaping light into art and revealing the hidden beauty of the universe. And in that revelation, we find a deeper appreciation for the intricate connections that bind the cosmos together, from the smallest grain of dust to the brightest star. Now, let's journey deeper into the cosmos to uncover another remarkable role of cosmic dust, one that goes beyond the formation of planets and into the very heart of star creation. Imagine a vast, dark cloud of cosmic dust drifting silently through space. Within this cloud, something extraordinary begins to happen. Gravity, that invisible force that shapes the universe, starts to pull the dust particles together. Slowly, almost imperceptibly, these tiny grains begin to clump, forming denser and denser regions within the cloud. Over time, these clumps grow larger, their gravitational pull intensifying, drawing in more dust and gas from their surroundings. This is the first step in the birth of a star. As these clumps continue to grow, they heat up under the pressure of their own gravity. The dust particles, once cold and scattered, now collide and compress, generating warmth at their core. This process continues until the temperature and pressure become so intense that nuclear fusion ignites and a new star is born. It's here, in these dusty stellar nurseries, that cosmic dust plays a pivotal role. Without it, the raw materials needed to form stars would remain scattered and diffuse, unable to come together in the way they do. Cosmic dust acts as the building blocks, the seeds from which stars emerge, lighting up the darkness of space. But the story doesn't end there. The birth of a star is just the beginning of a cosmic cycle. As stars form, they begin to shine, their light and energy pushing back against the surrounding dust and gas. This interplay between light and dust creates a dynamic environment where new stars can trigger the formation of even more stars. Shockwaves from stellar winds and supernovae ripple through the dust clouds, compressing them further and sparking the birth of new stellar generations. In this way, cosmic dust is not just a passive participant, but a key player in the ongoing cycle of star formation, connecting the birth of one star to the creation of many others. What's truly fascinating is how interconnected these processes are. The same cosmic dust that helps form planets around young stars also plays a crucial role in the birth of those stars themselves. It's a reminder that the universe operates as a vast, intricate web, where every element, no matter how small, has a part to play. From the tiniest grain of dust to the brightest star, each is linked in a cosmic dance that shapes the universe as we know it. And as we gaze up at the night sky, we're witnessing the results of this dance, a testament to the enduring power and beauty of cosmic dust. Now, let's take a closer look at the eternal dance between cosmic dust and the life cycle of stars. This delicate interplay is one of the most beautiful and fundamental processes in the universe. Cosmic dust, as we've seen, plays a vital role in the birth of stars, but its journey doesn't end there. In fact, it's also a product of the very stars it helps create. When stars reach the end of their lives, whether through a gentle fading or a dramatic supernova explosion, they release vast amounts of dust and gas back into space. This material, enriched with elements forged in the hearts of stars, becomes the raw material for new generations of stars and planets. Picture this: a massive star, having burned brightly for millions of years, exhausts its fuel and collapses under its own gravity. In its final moments, it explodes in a supernova, scattering its remains across the cosmos. Among these remains are tiny particles of dust, carrying with them the heavy elements created during the star's life. These particles drift through space, eventually joining other clouds of dust and gas. Over time, gravity pulls these clouds together, and the cycle begins anew. New stars form, surrounded by swirling disks of dust that may one day coalesce into planets. It's a cosmic recycling process, where the end of one star's life becomes the beginning of another's. But the story doesn't stop there. Even as stars age and evolve, they continue to shed dust into space. Red giants, for example, gently puff out their outer layers, creating vast clouds of dust that glow with the warmth of the star's fading light. Planetary nebulae, the remnants of sun-like stars, are another example. These glowing shells of gas and dust are not only stunning to behold, but also rich in the elements needed for future star and planet formation. In this way, cosmic dust is both a creator and a creation, a participant in the endless cycle of stellar birth, life, and death. This eternal dance of cosmic dust and stars is a reminder of the interconnectedness of the universe. Every grain of dust carries within it the history of the stars that came before, and every new star holds the potential to create more dust, more planets, and perhaps even more life. It's a cycle that has been repeating for billions of years and will continue long into the future, shaping the cosmos in ways we are only beginning to understand. As we gaze up at the night sky, we're not just seeing stars, we're witnessing the ongoing story of cosmic dust, a story that connects us all to the vast, beautiful universe. As we continue our journey through the cosmos, we now turn our attention to the mysteries that still shroud cosmic dust. Despite all we've learned, there's so much about these tiny particles that remains unknown, waiting to be uncovered. Where exactly does cosmic dust come from? How does it travel across such vast distances? And what secrets does it hold about the origins of the universe itself? These questions linger like whispers in the dark, inviting us to explore further. One of the most intriguing mysteries is the precise origin of cosmic dust. While we know it forms in the aftermath of dying stars, the exact mechanisms behind its creation are still being studied. Some dust may come from the gentle shedding of red giants, while other particles are forged in the fiery explosions of supernovas. Yet, there's also evidence that cosmic dust may have existed even before the first stars, forming in the early universe under conditions we can only begin to imagine. This raises the question, could cosmic dust be one of the oldest materials in existence, a relic from the dawn of time itself? Another puzzle lies in the journey of cosmic dust. How do these tiny particles, so small they are almost invisible, manage to travel across the vast emptiness of space? Stellar winds and gravitational forces play a role, but the details of how dust moves and accumulates in specific regions remain unclear. Some dust may drift for millions of years before finding its way into a nebula or a forming solar system, while other particles might be swept up by passing stars or planets. It's a journey filled with uncertainty, one that reminds us of the delicate balance that governs the cosmos. Perhaps the most captivating mystery is the role cosmic dust plays in the grand story of the universe. We know it's essential for forming stars and planets, but could it also hold clues to the origins of life? Some scientists believe that cosmic dust may have carried water and organic molecules to young planets like Earth, seeding the conditions for life to emerge. If true, this would mean that every living thing on our planet, and perhaps elsewhere in the universe, owes its existence in part to these tiny, unassuming particles. It's a thought that fills us with wonder and curiosity, urging us to look deeper into the cosmic dust that surrounds us. As we ponder these mysteries, we're reminded of how much there is still to discover. Cosmic dust, though small, holds the key to understanding some of the universe's biggest questions. It's a reminder that even the tiniest things can have a profound impact, shaping the cosmos in ways we're only beginning to comprehend. And as we gaze up at the night sky, we're left with a sense of awe, knowing that every speck of dust carries a story that's still being written, one grain at a time. Now, let's turn our gaze toward one of the most profound questions of all. Could cosmic dust hold the key to the origins of life itself? As we explore this idea, we find ourselves stepping into a realm where science and wonder intertwine, where the smallest particles might carry the answers to life's greatest mysteries. Cosmic dust, as we've seen, is more than just debris scattered across the universe. It's a carrier of essential ingredients, a cosmic courier delivering the building blocks of life to distant worlds. Among these particles, scientists have discovered traces of water and organic molecules compounds that are fundamental to life as we know it. Imagine, for a moment, these tiny grains drifting through the void, carrying within them the potential to spark life on a young, barren planet. It's a thought that fills us with both humility and hope, reminding us of the interconnectedness of all things in the cosmos. But how does this process unfold? Picture a young planet, still cooling from its fiery birth. Cosmic dust, carried by stellar winds or the gravitational pull of a nearby star, begins to settle on its surface. Over time, these particles accumulate, bringing with them water and organic molecules. As the planet's conditions stabilize, these ingredients mix and interact, setting the stage for the emergence of life. It's a slow, delicate process, one that might take millions of years or even longer. Yet, it's a process that has likely occurred countless times across the universe, on worlds we have yet to discover. This idea isn't just speculation. Scientists have found evidence of organic molecules in cosmic dust here in our own solar system. Comets and asteroids, which are rich in cosmic dust, have been shown to contain amino acids, the very building blocks of proteins. These findings suggest that cosmic dust may have played a crucial role in seeding life on Earth, and perhaps on other planets as well. It's a humbling thought, one that connects us to the vast expanse of the cosmos in ways we're only beginning to understand. As we reflect on this, we're reminded of the profound role that even the smallest particles can play in the grand tapestry of the universe. Cosmic dust, often overlooked, may hold the secrets to life's origins, not just here on Earth, but on distant worlds scattered across the galaxy. It's a reminder that the universe is full of possibilities, that life may exist in forms and places we have yet to imagine. And so, as we continue to explore the mysteries of cosmic dust, we're filled with a sense of hope and curiosity. What other secrets might these tiny particles hold? Could they lead us to discover life beyond our own planet? The answers are out there, waiting to be uncovered, one speck of dust at a time. Now, let's take a step back and consider the bigger picture, the role of cosmic dust in the grand story of cosmic evolution. Over billions of years, these tiny particles have played a quiet yet transformative role in shaping the universe as we know it. From the earliest moments after the Big Bang to the formation of galaxies, stars, and planets, cosmic dust has been a silent architect, weaving the fabric of the cosmos. In the early universe, cosmic dust began to form from the remnants of the first stars. These stars, massive and short-lived, exploded in spectacular supernovae, scattering their elements across the void. Among these elements were the seeds of cosmic dust, tiny grains of carbon, silicon, and other minerals. Over time, these particles began to clump together, drawn by the invisible hand of gravity. They became the building blocks of new stars and planets, setting the stage for the universe's ongoing evolution. As galaxies formed, cosmic dust played a crucial role in their development. It gathered in vast clouds, creating the dark lanes we see in spiral galaxies and the glowing nebulae that light up the night sky. Within these clouds, dust particles absorbed and scattered light, helping to cool the gas and allowing it to collapse into new stars. Without cosmic dust, the universe might have remained a cold, dark expanse, devoid of the vibrant structures we see today. But the story doesn't end there. Cosmic dust also shaped the evolution of planetary systems. As stars formed, the surrounding dust disks coalesced into planets, moons, and asteroids. These particles carried with them the essential ingredients for life: water, organic molecules, and minerals. Over time, they help to create the conditions necessary for life to emerge and thrive. In this way, cosmic dust has been a constant presence, guiding the universe from its chaotic beginnings to the ordered complexity we see today. Even now, cosmic dust continues to shape the cosmos. It drifts through interstellar space, seeding new stars and planets. It falls to the surfaces of worlds, delivering the raw materials for life, and it reflects the light of distant stars, creating the shimmering beauty of the night sky. In every corner of the universe, cosmic dust is at work, quietly shaping the future of the cosmos. As we reflect on this grand cosmic story, we're reminded of the profound interconnectedness of all things. From the smallest grain of dust to the largest galaxy, every part of the universe is linked by the threads of cosmic evolution. And in this vast, ever-changing tapestry, cosmic dust plays a role that is both humble and extraordinary, a reminder that even the smallest particles can shape the destiny of the universe. Now, let's turn our gaze closer to home and explore how humanity has sought to understand this cosmic marvel. The study of cosmic dust is not just a journey through the stars, it's also a story of human curiosity and ingenuity. Scientists, armed with telescopes, spacecraft, and microscopes, have dedicated themselves to unraveling the mysteries of these tiny particles that hold the secrets of the universe. One of the most remarkable ways we study cosmic dust is through space missions. Probes like Stardust and Rosetta have ventured into the depths of space, collecting samples of dust from comets and asteroids. These missions are like cosmic treasure hunts, bringing back tiny fragments of the universe to Earth. In laboratories, researchers examine these samples with incredible precision, using powerful microscopes to study their composition and structure. Each grain of dust tells a story, revealing clues about the origins of our solar system and the processes that shaped it. But not all cosmic dust needs to be collected in space to be studied. Some of it finds its way to Earth on its own, carried by meteorites or drifting through the atmosphere. Scientists carefully gather these particles, often from remote locations like Antarctica, where they are preserved in pristine conditions. These samples provide a window into the distant past, offering insights into the materials that existed long before our planet formed. The work of studying cosmic dust is quiet and meticulous, requiring patience and precision. Scientists spend countless hours analyzing data, running experiments, and piecing together the puzzle of the universe's history. It's a labor of love, driven by a desire to understand our place in the cosmos. Through their efforts, we gain a deeper appreciation for the role of cosmic dust in shaping not just the universe, but also our own world. As we continue to explore the cosmos, both near and far, the study of cosmic dust remains a vital part of our quest for knowledge. It reminds us that even the smallest particles can hold the answers to some of the biggest questions. And as we uncover these answers, we come closer to understanding the intricate dance of creation that has brought us here, to this moment, under a sky filled with the shimmering remnants of stars. As we look ahead, the story of cosmic dust continues to unfold, promising new discoveries and deeper insights into the cosmos. Imagine, for a moment, the countless particles of dust still drifting through the vastness of space, each one a potential seed for future worlds. These tiny fragments, born from the remnants of ancient stars, hold within them the blueprint for new planets, new solar systems, and perhaps even new possibilities for life. The universe is far from finished with its work of creation, and cosmic dust remains at the heart of this ongoing process. In the coming years, advancements in technology will allow us to explore cosmic dust in ways we can only begin to imagine. Space missions, equipped with more sophisticated instruments, will venture deeper into the cosmos, collecting samples from distant asteroids, comets, and even the atmospheres of exoplanets. These missions will bring us closer to understanding how cosmic dust contributes to the formation of planets beyond our solar system, shedding light on the diversity of worlds that exist in the universe. Back on Earth, laboratories will continue to refine their techniques, analyzing cosmic dust with ever greater precision. Each grain of dust, no matter how small, carries a wealth of information about the conditions in which it formed, the materials it contains, and the forces that shaped it. As we decode these microscopic messages, we'll gain a clearer picture of the universe's history and its future. Cosmic dust may even hold clues to the origins of life itself, offering hints about how organic molecules spread across the cosmos and found their way to young planets like ours. But the future of cosmic dust isn't just about science, it's also about wonder. As we peer into the night sky, we'll continue to marvel at the beauty of nebulas, those vast clouds of dust and gas where stars and planets are born. We'll watch as cosmic dust interacts with light, creating stunning displays like reflection nebulae and the soft glow of zodiacal light. These celestial phenomena remind us that the universe is not only a place of discovery, but also a source of endless inspiration. In the grand tapestry of the cosmos, cosmic dust plays a quiet yet essential role. It connects us to the past, shapes the present, and holds the promise of the future. As we continue to explore its mysteries, we'll uncover not just the secrets of the universe, but also a deeper understanding of our place within it. The journey of cosmic dust is far from over, and with each new discovery, we take another step toward unraveling the story of creation itself. Now let us turn our gaze upward to the night sky, where cosmic dust weaves its magic into the canvas of the universe. Each speck of dust, though invisible to the naked eye, plays a part in creating the breathtaking beauty that stretches above us. The Milky Way, our home galaxy, glows with a soft, ethereal light, its spiral arms dusted with countless particles that scatter and reflect starlight. This cosmic dust transforms the darkness into a shimmering tapestry, inviting us to lose ourselves in its quiet splendor. Beyond our galaxy, cosmic dust paints the skies of distant worlds. In the depths of space, it gathers in vast clouds, forming the backdrop for newborn stars and planets. These clouds, illuminated by the light of their stellar neighbors, glow with hues of blue, red, and gold, creating scenes that seem almost otherworldly. The dust acts as both a veil and a mirror, hiding some stars while revealing others, adding depth and mystery to the night sky. Even closer to home, cosmic dust leaves its mark. On clear, moonless nights, you might catch a glimpse of the zodiacal light, a faint, triangular glow that rises from the horizon. This gentle radiance is sunlight reflecting off the dust that orbits our sun, a reminder that even in the emptiness of space, beauty can be found in the smallest of things. It's a quiet phenomenon, one that requires patience and stillness to observe, but it speaks to the quiet, persistent presence of cosmic dust in our lives. As you look up at the stars, remember that the light you see has traveled vast distances, often passing through clouds of cosmic dust along the way. This dust, though often overlooked, shapes the way we see the universe, filtering and scattering light to create the patterns and colors that fill the night. It's a reminder that even the smallest particles can have a profound impact, shaping not just the cosmos, but our experience of it. The night sky, with its infinite expanse and timeless beauty, is a testament to the quiet power of cosmic dust. It invites us to pause, to reflect, and to marvel at the wonders of the universe. In its glow, we find not just beauty, but a connection to something greater, a reminder that we are part of a vast, interconnected cosmos, where even the tiniest grains of dust play a role in the grand story of creation. As we drift further into the story of cosmic dust, let us take a moment to explore how these tiny particles have not only shaped the universe, but also the human imagination. Across cultures and centuries, cosmic dust has inspired myths, stories, and art, weaving its way into the fabric of human creativity. It's a reminder that the cosmos has always been a source of wonder, not just for scientists, but for dreamers, storytellers, and artists alike. In ancient times, people looked to the stars and saw more than just points of light. They saw stories written in the heavens, tales of gods, heroes, and celestial beings. The shimmering dust that fills the night sky became part of these narratives, often seen as the remnants of divine battles or the scattered ashes of creation. In Greek mythology, for example, the Milky Way was said to have been formed by the spilled milk of the goddess Hera, a poetic explanation for the luminous band of dust and stars that stretches across the sky. These myths, though born of imagination, reflect a deep connection between humanity and the cosmos, a desire to find meaning in the vastness above. Beyond mythology, cosmic dust has also found its way into art and literature. Poets have long been captivated by its ethereal beauty, using it as a metaphor for the fleeting nature of life or the infinite possibilities of the universe. In paintings, artists have sought to capture the glow of starlight filtering through dust clouds, creating works that evoke both the mystery and the majesty of space. Even in modern times, cosmic dust continues to inspire, appearing in science fiction stories as a symbol of exploration and discovery, a reminder that the universe is full of secrets waiting to be uncovered. This connection between cosmic dust and human creativity is more than just a coincidence. It speaks to something fundamental about our relationship with the cosmos. The dust that drifts through space is a tangible link between the vastness of the universe and the intimate world of human experience. It reminds us that we are part of something much larger, a story that began long before us and will continue long after. In the quiet moments when we gaze at the stars, we are not just observers, but participants in this grand narrative, adding our own stories to the tapestry of creation. As we reflect on the role of cosmic dust in mythology and culture, we are reminded of the power of the cosmos to inspire. It invites us to dream, to create, and to find beauty in the smallest of things. Whether through ancient myths, timeless art, or modern stories, cosmic dust continues to spark our imagination, connecting us to the universe in ways that are both profound and deeply personal. And as we continue our journey through the cosmos, let us carry this sense of wonder with us, allowing it to guide our thoughts and fuel our creativity. Now, let us journey even further back in time, to the very beginning of everything. Cosmic dust, those tiny particles that drift through space, has a story that begins with the birth of the universe itself. It all started with the Big Bang, the moment when the universe burst into existence, filled with energy and potential. In those first few moments, the universe was a seething, chaotic sea of particles, too hot and dense for anything solid to form. But as it expanded and cooled, the first elements began to emerge, like hydrogen and helium, the simplest building blocks of all matter. Over millions of years, these elements began to clump together, forming clouds of gas and dust. This was the first cosmic dust, the raw material from which everything in the universe would eventually be made. As gravity pulled these clouds closer, they began to collapse, igniting the first stars. These stars burned brightly, fusing hydrogen and helium into heavier elements like carbon, oxygen, and iron. And when these stars reached the end of their lives, they exploded in spectacular supernovas, scattering their newly formed elements across the cosmos. It was from this stardust that the next generation of stars and planets would form, including our own solar system. Cosmic dust, then, is not just a remnant of the universe's past. It is a living record of its history. Each grain of dust carries within it the story of the stars that came before, the elements forged in their cores, and the explosions that sent them hurtling through space. It is a reminder that everything we see around us, from the ground beneath our feet to the stars above, is made of the same ancient stardust. We are, quite literally, made of the universe itself. As we trace the journey of cosmic dust, from the Big Bang to the present day, we are reminded of the incredible scale of time and space. The universe has been expanding and evolving for over 13 billion years, and cosmic dust has been there every step of the way, silently shaping the cosmos. It is a story of creation and destruction, of beginnings and endings, all woven together in the fabric of the universe. And as we look up at the night sky, we are not just seeing the light of distant stars. We are seeing the echoes of the Big Bang itself, the faint glow of cosmic dust that has traveled across the ages to reach us. This connection between cosmic dust and the origins of the universe is a profound one. It reminds us that we are part of a story much larger than ourselves, a story that began with a single, unimaginable moment and has been unfolding ever since. And as we continue to explore the cosmos, we carry with us the knowledge that we are made of the same stardust that has shaped the universe from its very beginning. It is a humbling and awe-inspiring thought, one that invites us to marvel at the beauty and complexity of the cosmos and to find our place within it. Now, let us turn our gaze to the delicate balance that cosmic dust helps maintain in the universe. Imagine the cosmos as a vast, interconnected web, where every particle, every star, and every planet plays a part in a grand cosmic dance. Cosmic dust, though small and seemingly insignificant, is one of the key players in this intricate balance. It acts as both a creator and a sustainer, shaping the universe in ways that are both profound and subtle. One of the most vital roles cosmic dust plays is in the formation of stars. When clouds of gas and dust gather in the cold, dark regions of space, they begin to collapse under their own gravity. Cosmic dust acts as a catalyst in this process, helping to cool the gas and allowing it to condense into denser clumps. Without this dust, the gas would remain too hot and diffuse, unable to form the dense cores needed to ignite new stars. In this way, cosmic dust is not just a byproduct of the universe. It is a necessary ingredient for the birth of stars, the very engines that power the cosmos. But the role of cosmic dust doesn't end with star formation. It also plays a crucial part in the creation of planets. As stars form, they are often surrounded by swirling disks of gas and dust. Over time, the dust particles within these disks begin to stick together, forming larger and larger clumps. These clumps eventually grow into planetesimals, the building blocks of planets. Without cosmic dust, this process would be impossible, and the universe would be devoid of the rocky worlds, gas giants, and icy moons that populate it today. Cosmic dust also helps regulate the temperature of the universe. When starlight passes through clouds of dust, some of the light is absorbed and re-emitted as heat. This process helps to distribute energy more evenly throughout space, preventing regions from becoming too hot or too cold. In this way, cosmic dust acts as a kind of cosmic thermostat, maintaining the delicate balance needed for stars, planets, and even life to exist. Moreover, cosmic dust plays a role in the recycling of elements within the universe. When stars die, they release their material back into space, enriching the surrounding clouds of gas and dust with heavier elements. This enriched dust then becomes part of new stars, planets, and even living organisms. It is a cycle that has been repeating for billions of years, ensuring that the universe remains vibrant and full of potential. In the grand tapestry of the cosmos, cosmic dust is a thread that weaves together the past, present, and future. It is a reminder that the universe is not a static place, but a dynamic, ever-changing system where every particle has a role to play. From the birth of stars to the formation of planets, from the regulation of temperature to the recycling of elements, cosmic dust is a silent guardian of the universe's balance. It is a testament to the beauty and complexity of the cosmos, and a reminder that even the smallest things can have the greatest impact. As we bring our journey through the cosmos to a close, let us take a moment to reflect on the remarkable story of cosmic dust. From its humble beginnings as the remnants of dying stars and the debris of ancient collisions, this seemingly insignificant substance has played a monumental role in shaping the universe as we know it. It is the quiet architect of stars, the gentle sculptor of planets, and the silent carrier of life's essential ingredients. Without cosmic dust, the universe would be a far emptier, colder, and less vibrant place. Think of the countless particles of dust that drift through the vastness of space, each one a tiny piece of a much larger puzzle. Over billions of years, these particles have come together, clumping and colliding, growing into the seeds of planets and the cradles of life. They have carried water and organic molecules across the cosmos, delivering the building blocks of life to young worlds like our own. They have danced in the light of newborn stars, creating the breathtaking beauty of nebulas and the shimmering glow of the night sky. Cosmic dust is more than just a physical substance. It is a symbol of the universe's endless creativity and resilience. It reminds us that even the smallest things can have a profound impact, and that the universe is a place of constant change and renewal. From the fiery hearts of stars to the quiet depths of space, cosmic dust has been there, quietly shaping the cosmos and weaving the story of existence. As you drift off to sleep tonight, let your mind wander among the stars. Imagine the countless particles of dust floating through the darkness, each one a tiny piece of the universe's grand design. Picture the swirling clouds of nebulas, the glowing rings of distant planets, and the shimmering trails of dust that light up the night sky. Let the beauty and mystery of the cosmos fill your dreams, and remember that you, too, are part of this incredible story. Thank you for joining us on this journey through the universe. If you enjoyed this exploration of cosmic dust and its role in the cosmos, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss a journey into the wonders of space. Until next time, may your dreams be filled with the beauty and wonder of the stars. Good night. you.